Okay, I guess we can start with homework first and then the rest of the people can come in later. So for the ones of you who are here, can you please open camera so I'm not talking to myself all the time? Thank you guys. Right, over here. This is the first assignment from yesterday. It's a coding math exercise. Does anyone have a solution ready that they wanted to share about on this problem? Anyone? Okay. Right, if no one's had it, okay. Nobody have solutions to this? Okay, I got one solution. Let's see, even equals to for I. Okay, so Ian sent me the following solution. It seems correct to me. Let's check. Yep. So what Ian did over here is that he sat a variable, which is um, a counter that records the amount of time that an even number appeared in this list, because what the exercise asks us to do is for every even number in the list, we add one, and then we have to output the amount of even numbers in the list. So he defined a counter as a variable and stored it in the computer. And then what he did is he had a for loop. So for I and nums is the array over here. So for I and nums means for every single item in the list. It iterates through every single item in the list. And then this condition over here is used to decide if the number is even or odd. We should remember that this percent mark over here is the modulus calculation, which means that it takes the remainder of the division process. And then if it's an even number divided by 2, the remainder will always be 0. So this is why this line can be used to consider if a number is odd or even. And then if it is even, then the counter is added 1. And then for every single item in the list, you do the same operation. And then last of all, you do return even. Very nice solution. All right, so this is the first homework. Does anyone have any questions to this? Everyone's good with this problem. Okay. The second homework assignment from yesterday is printing this diamond, and then we wanted to make it into the function so that we can do different lengths. For lengths of 5, the largest row will have 2n-1, which means if it's 5, this line should have 9 stars, so on and so forth. Does anyone have a solution to this one? This is kind of hard. It's okay if you guys didn't get this one. I'll show you guys how this logic works. Anyone have the code for this diamond printing exercise? Anyone? Okay, I'll start demonstrating how to solve this problem, and if you guys have a solution, just send it in the chat and I'll look at it. So first of all, we define a function, def print diamond. This n over here is the parameter that we want to take so that we know how big the diamond is going to be. And then inside the function, we start with a for loop. So the way we want to tackle this is that we want to split the diamond into two halves, right? So we want to print this half first, and then we want to print this half. So we should have two different for loops to finish this process. And then so we have the first for loop for item range of n. This tells us if our input was 5 layers, then it will put 5 layers on the top, 4 layers on the bottom. If it's 6, it'll be 6 on top, 5 on bottom, so on and so forth. And then so the way we want this diamond to be printed is by printing the spaces in the front, and then you print the star in the end of the sentence. So you can see that the first line over here, we have 4 spaces, and then we have 1 star. So we have to think of a way that we can do 4 spaces, 3 spaces, 2 spaces, 1 spaces, no spaces, and then star will be 1 star, 3 stars, 5 stars, 7 stars, and 9 stars. So let's first consider the spaces. For j range. This is a new loop. So for every single line, we have to print multiple spaces, and this for loop is to print the spaces. For loop spaces. The condition we wanted to fill in here is n minus I minus 1. The reason behind this is that remember in a for loop, this n over here is exclusive at the end and then it's inclusive at the start. So which means that I starts at 0 and then it will do I equals to I plus 1, I plus 1, I plus 1 all the way until I is equal to n minus 1 because it's exclusive at the end. So what this does is that in the first iteration for I in range n, let's say n equal to 5, just as an example. So in the first iteration, it will print spaces n minus I minus 1 amount of times, which is 5 minus 0 minus 1, which is 4 spaces. And then in the next iteration, I is going to be 1, n is still 5. So n minus 1 minus 1, it will be 3 spaces, so on and so forth. So this for loop takes care of printing out the spaces. And then we can just say under this print space and with this this end word over here, it means that we don't want to switch a line after each space, because if you just say print, it will do space, enter, space, enter, space, enter, which is not what we want. But if we add the end over here, it'll make sure that all the spaces are printed under the first line. All right, is everyone with me still? Do you have any question? No? Okay. And next you want to say print, this will be switching. So this for loop over here will be taking care of the spaces, and now we want to print the stars. So we have to have a new for loop for, let's say, k in range. Condition prints the stars. In this case, the stars, we print spaces, we print 4, 3, 2, 1, 0, but the stars, it goes, we want to have it increase every time the loop is ran. So the first iteration, we want to print 1, the second iteration, we want to print 3, the third time is 5, 7, 9, so on and so forth, depending on how many, what's the height you want to have. So the way we do this is we want to do 2 times I plus 1. This means that when I is 0, you print this first star. When I goes to 1, it's in the second line, and you print 2 times 1 plus 1, which is 3. And then when I is equal to 2, you do 2 times 2 plus 1, which is equal to 5, so on and so forth. So every time you add this 1 star in the front, and then you add this 1 star in the back. Similarly, we have to say print stars and equals to null. Print all stars, first line. And okay, so does everyone understand this section of how this is going to be this part, the first half of the star? Anyone have any questions? All good? Okay, print. Let's see if I made any mistakes. I'm not too sure. Oops, didn't run. Uh, well, okay, it's telling me that it's not printing. The star is in the bottom. Okay, it's not printing the spaces, but you guys can see that like there's 1, 3, 5, 7, and 9. I think it will be fixed after all the code is completed. So let's just move on for now. And next we have to print the bottom half, which is 1 line smaller than the first half. So we want to open a new for loop for I in range of, here we said n minus 1, n minus I minus 1. And then since the second half have 1 less line compared to the first half, the condition that we should put in here should be n minus 2, -1, -1. The -1 means that the for loop ends at -1, and then it goes backwards. So normally I would be 0, I would be 1, 2, 3, 4, all the way is equal to n. But then if we define a for loop like this, it will be like I is equal to 5 in the beginning, and then it will be 5, 4, 3, 2, 1, all the way to -1. And this is the syntax you guys want to remember if you want to like run a loop backwards. So let's make a note here. Syntax. Back. All right, and then inside here, it's the same logic for j and range. Oops. J n minus. Everything else in here will be the same because it's just printing the same thing instead. The only difference is that it's running it backwards instead of running it forward. So print space and range 2 times I plus 1. All right, is everyone with me still? Does everyone understand how this is going to be the second half? And then the loops runs backward, it prints one less line so it can form a diamond instead of a symmetrical triangular shape. Does anyone understand this part? Any questions? No? Okay, let's just finish off the program then. So you would say print, no, I think I have to get rid of this line. And I think this program over here should print the diamond. Let's see. Yep, we can see that it printed a diamond. Maximum length in a line is 2n minus 1. We can adjust this parameter over here, make it smaller or bigger. So 8, it will be bigger, and then let's do 3, it will be super small. 15, it'll be super big, like this. So does everyone understand this code? Does anyone want me to send this code in chat so you guys can look at it? It's a pretty complicated logic for nested loops, and I don't think we'll be doing anything harder than this in terms of loops. Okay, I'll send this to the chat so you guys can look over this code. All right, any questions? Anyone want to ask anything? Nope, okay. Then let's go on to the slides for today. There's not much slides for today. There's only 2 concepts. Okay, the first concept we want to talk about is classes. A class in Python is like a structure for creating an object. You kind of defines an object to have a set of attributes and a set of function. Pretty much you can define a class and then you can put objects under the class so they follow the behavior of the class. That might be a little bit confusing, but let's first look at the syntax. Oh, in a class, we need to have the name of the class, an object, which is called an instance of the class, and then we have to have attributes in a class, and we have function that belongs to the class. Okay, let's go to class node and I'll show you guys an example. Let's say I want to create a new class called, I don't know, just class dog. This class is going to describe and show some behaviors of, let's say, a dog. So what we do here is define a class. Self name age. So this first parameter I put in here is called self. This is called the instance for a class. Instance. Can I do this? No, I can't. Okay. Self is instance. It means that we're using self as an example. So we will be assigning values to self, and then we will be like assigning behaviors to self. And this name can be anything. just like a random name is all right. It's just that you want to make sure that you always refer to this parameter when you are doing like examples in this class definition. And then this init function over here, init, you um init define the thing. So when this init function is ran, it will be activated when you assign a new object under this class, and then the procedure will always be ran so that you can check if the object can actually belong in this class. And then the names and ages are just attributes. You can add infinitely many. You can add hobby. You can add, I don't know, weight, color. So it doesn't matter how many attributes you have. You can have infinitely as many, but just remember that you have to define every single attributes. And I'm going to show you guys how to do that. Under the init is where we put our definitions to those attributes. So we put self, the name of the instance, name equals the name. And then self age is equal to age. This means that we have created two variables, one called self.name, second called self.age. When you type this variable, let's say self.name, it will automatically extract the value in this parameter. So if I say my dog, let's name it buddy 3. This buddy over here refers to this name parameter, and then this 3 over here refers to the age parameter. And if I run my dog buddy and I say my dog dot name, this will extract this buddy, and then in a terminal, if I run the code, it will just print buddy. So that's how you should understand it as a variable, and then it stores
蚂蚁是吧？
by extracting the name in the parameters.
嗯，
Oh,
是
do you
吧？
mind muting yourself if you don't have any questions? Or is there any questions? Okay. Let's move on to other functionalities in the class. You can also define functions. So let's make a new function called define bark with instance of self. Putting a self in here pretty much puts everything in this under the function, which means that you will need a parameter that satisfy name and age. So a parameter such as my dog, the example we just used, buddy, age, would suffice this function. But then if you just put my dog, it wouldn't suffice this function. It will show you error by telling you you lack parameters and you lack arguments. So this part you can just share like a normal, you can just share like a normal function. You can say print, let's say self name. So this function over here, I think you guys can all understand it. It says print extract a self name. So whatever the user input as self name says woof. So let's try it out. Let's say my dog equals to dog buddy 3. This is putting this object called my dog. It's a newly defined object under this class called dog, so that my dog have all the attributes defined over here, and it can perform all the functions that we defined below. So after defining this class, I can say print my dog dot name, what I was talking about, and then we can also say my dog bark. Let's try this out. Okay, so it first printed buddy, which is my dog name. It extracted my parameter over here as it's defined in this line. And then it said Buddy says woof, which is this function over here that I defined, and it tells it'll tell the computer what to say when you see the class, this function in this class being executed. Is everyone with me? Does anyone have any questions or all good? Okay, I'll just make some notes over here. This is the attribute attribute. Okay, so let's try an exercise. How about you guys take this class and then let's add an attribute to this class. So over here, we want to define something else. You also have to add it in this bracket over here. Let's just add whatever attributes you guys feel like, and then to see if you can extract it down here by doing print my dog, and then you put your new attribute. Okay, I'll give you guys a few minutes to try this out and then to see if you guys can add in new attributes and print it out in the terminal. I'll send this code in the chat, so for those of you who wanted to copy. Okay, I've seen a few questions. Somebody asked, what does the F self name mean? Oh, this is kind of like a syntax in Python so that I can include this parameter inside the quotation marks without it just printing out what it actually says. So if I take out the F, it'll just print, let's see. It'll show you it's wrong because, oh, it's not wrong. It'll say self.name says wolf, which is not what we want. We wanted to extract this element. So there's multiple methods to do this. One was the example I used, which is to add a F here. It just means to print this line as the value stored in it as a parameter. So adding an F here will make it print what we actually wanted to print. Buddy says wolf. Another way to do this is take this out of the quotation marks, add a comma, and I think this should also, well, this should also give us the same result. Buddy says, well, you don't need the brackets here anymore. Buddy says wolf. So those are just two different ways, and then you can view the f as a pointer. It points the parameter toward the value stored within the parameter, and then yeah, it's pretty much just different ways you can tackle this. Let me put the bracket back. Okay, someone said I have a name error saying dog is not defined. Can you send me your code if you say you have a name error? I feel like it might be that you don't have a line over here, you're missing this line, or you're missing this line, or some sort of indentation errors. Do you mind sharing your code, Michael, if you have an error? Okay, for the rest of the group, how are you doing on adding a new attribute to this? Have anyone made it or added a new attribute so they can extract on the bottom? Anyone? All right. Okay, I'll show you guys how to do this and then please follow along and then do this on yourself. Let's say we want to add an attribute called, I don't know, hobby. And we can say self dot hobby equals to hobby. Defines a new attribute. Okay, when we change the amount of arguments here, what we also have to change is the amount of arguments that we input into this class. So instead of only putting buddy, age of 3, we have to add a new input. Let's say hobby is running around. And so if I do my dog print my dog dot hobby. This should give me running around. Yep, running around. So this extracted this parameter because it's defined in a class that self.hobby, instant.hobby is just equal to the parameter in a position of hobby. And what we can also do to this is we can add a function. Def, let's just name it def talk self. New function. Okay, print. This time let's use the normal way we should be typing this. So my hobby is hobby and self.hobby. Okay, let's see if it works. My hobby dot top. Yep, this printed my hobby is running around, which means that we added this new function and we called the new function and the new function works and it says what we wanted to see in the terminal, and that's pretty good. Does everyone understand so far? So far, so good, everyone? Anyone have any questions or any issues in your code? Okay, so after you guys have seen me do this already, can you guys try again to add one more new attributes? So add another attribute and add another function here. This is really important to understand because the second half of class, we're gonna use a class from an outside source. So it's really important for you all to understand how classes actually work. So I'll give you guys a few minutes to try add a new attribute and add a new function. And please send me your solutions if you're finished. All right, checking back on you guys. Did anyone successfully add a new attribute and successfully added a new function? Anyone? Should be pretty easy. Just follow my structure, add a comma here, name something else, define over here self dot name equals the name, and then add a function here, define function, and do whatever you all want it to say. Okay, I see multiple people saying that there's have an error. Do you guys Ian, would you like to share your screen and then I can look at your code, or you can just send your code directly to me as well. Whichever you want to do, just tell me. And I deleted it and I can't get back. Okay, give me just a sec. Plus, okay, let's see what's wrong with the code over here. Class dog, define a class, def init, self name hobby weight, self age hobby. Okay, so Ian, what you're missing over here is that once you define a parameter, you also wanted to define a variable that tells the computer where the parameter should go. So here it should be self dot weight equals to weight. Defines stores a parameter in a variable. Should be better. Stores can't type today. Yep, and then let's see. Bark, talk, info, I wait, self info. Let's run it. I think this should work, right? 203, 203. Okay, let's uncomment this. My dog dot wait. My dog. Oh, over here, you define it info, so you can't name it weight over here because the function name have to be consistent with the function name you defined up here and down here. So either you change this to info or you can change that to weight, either is fine. And this should work. Yep. My hobby is chewing bones, CO3, I weigh 203. Yep, this code works, and then this is a correct way to add attributes and stuff. Let's see, someone else gave me another code. Let's see how to debug this code. Class dog, init age hobby. Oh, never mind. That's just a quote. Never mind. Okay. Any other questions or any other solutions you guys want to share? All right. If you have any questions, just type in the chat and then I'll answer it once I see them. Okay, let's review classes real quick. Remember that a class is a blueprint for creating a new object. It's pretty much once you define a variable as a class, it will obtain many attributes and it will obtain many different functions, but you have to keep the parameters in place. And the amount of parameters you define in the class is the amount of parameters you have to put in to define the object as a part of the class. And then remember, to form a class, you always have to have those key concepts. You have to have a class name, an object or instance. In this case is self. See, we used all self as examples of instances. And in real life, this self would actually just be this variable name here. So my dog goes into the position of self, and that's instances. And we have attributes and we have methods. So we have a set of attributes and we have a set of methods, which is pretty much what we're allowing the class to do and the amount of information that we're storing in the class. All right, that should be all good. So okay, any questions before we move on? We're gonna talk about libraries next. Any questions about classes? Okay, let's move on then. So next, a very important concept in Python is called libraries. Python itself is actually a big library. You see all the in Python we can use all the print functions, the while functions, all those different functions that we're allowed to use. These are all actually a form of library. So what is library? Library is a set of code written by other people that you can take it and just use it by calling out the name of the function without knowing how it's actually written. So we see the definition here, a collection of pre-written code that user can use to optimize tasks. So this is pretty much just functions you can use, but it's written by other people. So some examples that we would use, time, of course, random, NumPy, Turtle. There's also mass, OS, systems. OS and system connects Python to your operating system, which allows you to detect movements on your computer, such as like clicking and sending data from local to cloud. That's from OS and system. And then time just allows you to count the time. You can count seconds, count minutes. I'm going to show you guys how to write like a countdown code later. And then random, we've used random, it's just generating random numbers. And then turtle is what we're going to be using for the second half of class. So let's go back to the example and see how we should use libraries. So when using libraries, first of all, we have to do some research to know what is in different libraries. So with prior knowledge, I already know that if I want to do, let's say square root of 16. So normally if I just say print square root of 16, it wouldn't know what square root is and it wouldn't know how to like calculate it mathematically. And so I also don't know how to like just calculate square root for every single number. So what we do here is we import a library called import mass. I think it's called mass. Import mass. And under this mass library, there's a lot of different functionalities, including the square root. And there's a lot of other stuff in the library. I'm not sure how many functions exactly there are, but let's just say print square root of 16. I think this should work. Square root is not defined. It's probably a syntax error. I'm sorry, I don't actually remember the syntax for mass, but the thing is the point is if you import a library, you can do functions that you're not usually able to do. Let's try something else that I do remember. So let's say import time. And normally when you print an item for while true print hello, it'll do it with the name hello is not defined. Okay. Quotation marks, can't forget that. Normally you'll do it like instantly. It won't give you any time in between. It'll just do it as fast as the CPU can handle, and it'll do it as many times as fast as it can. So which is usually not what we want in a real life example. So in a real life example, let's say we want to print hello once every 2 seconds. So here we got to do is import time. I'll to print hello. I believe the syntax is time dot sleep uh is equal to sorry, no sleep one. And this code should have the computer count 1 second every time before it prints hello. Let's just try it out. I'm not entirely sure as well. See? Okay. Hello, 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 hello. It will wait for a bit every time it puts instead of just spamming it as fast as the computer can handle. And you can see that the syntax over here, you have to put the library name in front and then you put the functions in the library. So this is pretty much just library. Let me see if I can figure out how to do mass. Import mass. A equals to not quite sure if this is going to be correct, but yep, it's correct. So you have to put the library name in front and then you have to put a dot, which indicates that you're using a function under this library, and then type out the function name 16. So the thing with library is that we don't have to remember everything in the library. We don't have to know what functions are in what library. Usually in Python, you just go on Google and search up, like, I want to use this function. Does any library contains the function? But there's like a few basics you want to know always. So time, random, turtle is for graphic programming, NumPy is for more complicated calculations, and yeah, time is for time, OS and system is for connecting to your computer. Those are the ones that you guys should remember when using Python programming because usually they're the most used. Pretty much all of the programs that I've been creating recently includes time, mass, random. So yeah, and you can you can define infinitely amount of libraries. You can import as many libraries as you want. You can do import random, import OS, import sys, however many you want to do. And the order also doesn't matter. You can do it in any order you want. But like if you only import, it's not going to do anything. So if I do this, terminal is null because there's nothing to run for the program. And we have to call it out. So let's say num equals to random, the library name dot randint. This is the function name, 1 to 100. This is the function we use generating a random number between 1 and 100, the homework for either first class or second class, I forgot. So print number 56, 83, 27. So the syntax, let's make some notes over here. Library name, function name, dot function name, required parameter. So let's have I'm gonna have you guys practice this really quick. So just make a just make a short program that um it generates let's say it generates a number, a random number every 2 seconds, generates number 2 seconds. How about let's just try this first. It generates a number every 2 seconds. I'm gonna give you guys a few minutes um to try this out. So the libraries you will be using for this, you will be using time and using random. So remember to import time and remember to import random. Those always goes on the top, very top of the program before everything else starts. So yeah, I didn't see the time library section. Okay, so for time for countdown, the function you want to use is sleep. So combining those, it will be time dot sleep, and then here in the brackets, it will be the amount of time that you wanted to wait for. And then for random, we've used it a lot, so it's called random dot randint. Okay, with these range, with these, can you guys try to like make a program that generates a random number every 2 seconds, every 1 second, or every like once in a while? Should be pretty easy. It's just a while loop, while true, and then try to like write down the function. All right, any solutions to the short problem that I assigned to you guys? Generate random number every. When do you put in time dot sleep? Okay. All right, let me just demonstrate to you guys. So we want to do it forever. So while true until we kill the program. And we want to say a equals to, let's name a number just so it's clear. Num is equal to random dot randint 1 to 100. And then you say print num. So without adding the time here, we will see the code doing, it'll generate it forever, and we don't want that. We want to have it wait. So after this print line, you will say time dot sleep, however long you want. So let's just say 2. So every 2 seconds. 39, 1, 2, 63, 1, 2, 45, 1, 2, 39, 1, 2. So you can see that this is how you can combine different libraries and using functions from different libraries. And together you can create programs that have a bit more of diversity. If you want to make it fancy, you can even say that if num equals, oh, we should do it before the sleep. If num equals to 16, print mass dot square root num. This pretty much just means that if number is randomly generated to 16, print the square root of the number, and yeah, pretty much just end the program and we say break. It will probably not generate to 16, but like just as an example, you can also always like mash different libraries together. You can always mash different functions together, and it will still work, and it will create a very versatile program, and you can be using a lot of different tools from different sources. It's not giving me 16, which is fine. Okay, next up, okay, first of all, does anyone have any questions before I move on to a more advanced example? Anyone? Any questions, concerns? No? All right. Okay, we have 8 more minutes left. Okay, I'll just do a short demo of a more advanced code that you can achieve using library. Don't worry if you don't understand this code. This code is pretty advanced, and then it involves some content that we haven't covered yet. Just try to follow along, and I'll try my best to explain it to you guys after I finish writing it. So I'm gonna be creating a stopwatch that counts down from the whatever time we feed it. All right. Okay, so first we have to, of course, it's associated with time, so we have to import time. And then we define a function that counts parameters for the amount of seconds we want it to count down from. While seconds bigger than 0. This line is also a part of the time library. It pretty much tells the computer's relationship between minutes and seconds. It pretty much just says that there's 60 seconds every minute, and then you want to take that and put it in the seconds position. So don't worry about understanding all of this. It's slightly more advanced, but I'm just showing you guys how like library can be utilized to like do something that you wouldn't normally expect to be able to be programmed. Timer equals to this over here means the way I want the time to be printed. So after this will print as 0.0 as a countdown. So this line pretty much defines the structure over here, and then it does pretty much just that. Format. This backslash R means it turns to a new line and it'll every time the time is printed, it'll switch to a new line and then so on and so forth. Time dot. Okay, this is the part where times involved, time dot sleep. What this means that for every single time all of those is executed, we have to wait 1 second so the purpose of a countdown timer can actually work. Seconds then equals to seconds minus 1. So every time, wait, what the? Yep, so every time the loop is iterated, the second will decrease by 1 until the second is 0. So after the while loop ends, print time is up. Count down timer. Let's see. Name second is not defined. Second. Line 4, 1 second. Missed the S over here. Keep all variables name consistent. All right. So you can see that at the little animation over here, 10, 9, 8, 6, 7, 6, 5, 4, 3, 2, 1. Time is up. So you can see that although this part might be a little bit complicated because it's about formatting and like excerpting in a specific way in a specific format and specific font, you can still see that the important part is over here. So print time equals to sleep to 1, and then seconds equals to second to minus 1. And we can change whatever times we want to do. 30 counts down from 30. So we can see that it's pretty cool. We can do a lot of stuff with libraries. Libraries are super powerful, and it can do a lot of functions that we wouldn't think that are able to be programmed just on ourselves. So this is why we want to use library all the time, and it's very super important. Let's go back to slides. Not too much to review. Okay, so it's 7:57, and before you guys head on to the 10-minute break, can everyone, I'm gonna send this into the chat, and then whoever, so for what those of you have already registered, it's all right, just go on to your break, and then for whoever haven't registered yet, can you please go to this website and sign up for an account, because we will be using this as a tool in our second half of class. And that's that. You guys can have your 10-minute break, and then I'll see you guys at 8:07. Okay, let's start the second half of class by a small practice. We just did this time. Okay, since we just did this timer and I sent out the code in the chat, can we try making a countdown timer with a random time? So all of these would still be the same. But then when you call the thing, let's see, count down timer. Let's try to make this a random number. Random. This should be pretty easy and shouldn't take you too long. It's just random.randint, and then it's just a warm up so everyone can start to get back to class and kind of review what we learned in the first half. I'll give you guys a few minutes to try this out. Just input a random number as a parameter. That's the task. All right, anyone have any ideas? If you don't want to, you don't have to type all of these out. Just tell me what I should put in the bracket for my timer. It doesn't print. Oh, for those of you who are running this timer in Google Colab, Google Colab doesn't take this line, so it wouldn't print the time. But like if you put it in any other like this website, for example, onlinepython.com, I'll send this in the chat. It will print out the time. It's just Google Colab being kind of weird. And yeah, so does anyone know what should I put in here? Does anyone want to give it a try? I don't know. Right. So let's say so parameter is random. What should be random defined as? Anyone? Right. I'll just show you the solution. Should be pretty easy. So you have to import. Oh, I see an answer. Random.randin 160. Yep, that's correct. So what you pretty much just do is import random number then equals the random random and whatever range you wanted to put. And then this should have a countdown. Oh, I forgot. I can't run this over here. I would have to go to this page. Yep. It generates a random number and then it starts counting down. It's pretty large, so I'm not gonna wait till it finishes. All right, that's just a warm up for the start of the second half. And let's go to Replit. So is everyone already um good on creating an account on Replit? We're going to use this for a tool to run Turtle, which is another really popular and basic Python library for graphic programming. So can I see some signs? If you all have Replit ready, I can move on. And then if not, I'll wait for a few more minutes and then show you guys how to create a new Replit document. I have Replit. Okay, I know Jaden's have it. I know Ian's have it. Morgan's got it. For the rest, are you guys all right? Are you guys signing up or do you have any issues? Michael, Chloe, Takashi, Paris, are you guys okay with signing up for Replit? Because I don't want to just move on without sign up issues. I'm not quite sure if Turtle can be ran on Collab. Let me just try that really quick. Let me try this out. Import Turtle. Seems like it doesn't run on Collab. So so Paris, if you have issues logging on, you can just what about you just like record the code in here and then I'll send you a version of this document. So after class, if you can sign in, you can try this out. But for now, just follow my instructions and follow my class. Okay, I think everybody else already got it. So once you're in Replit, click this create REPL, REPL blue button over here. It will bring you to a new document. And then you want to select Python with Turtle. So it have the library of Turtle pre-installed and you don't have to do any installations on your computer. So Python with Turtle, you can name it everything. I'm just gonna name it the for class notes. Anything fine. And then remember it should be Python with Turtle, give it a title and then click create REPL. And it should lead you to this blank document with all of these code already over here. Can everyone give me a sign once they're here and then I can start talking about the second half of class. All right, I see Ian got it. Let's wait for everybody else. Jaden's got it. What are you supposed to? Once you're in REPL, let me just open a new document, REPL.com. Click this create REPL button over here, and then select Python with Turtle. So Python wizard on the left, and then give it a title and say click create REPL. So that will give you a new document. All right, so I think Morgan and Chloe, are you guys doing all right? Or do you guys need another minute to create this new document? I don't want to leave anyone behind because it will be hard to catch up after. All right, we all good? Okay, let me start demonstrating Turtle. So Turtle is a graphic program. You can see it as a pen and then you can draw with a pen. So let's just run the example code. All of you should already have this on your screen. It's already pre-written by REPL. It's very helpful. So let's see what this code does without understanding it. So you can see that it drew a box over here in the bottom. It's red, green, blue, yellow. It drew a box. So we can see that Turtle is used for graphic programming. It can be used to draw stuff, to like write stuff, to type stuff, all of those. And now I will start explaining how this code work. So we can see that Turtle is a library. So we said import Turtle at the very top to import this library. And within the library, Turtle have defined different classes for you. So screen house set. So turtle.screen. Screen is a class defined by Turtle, and then we're assigning this variable called screen, this class so that it obtains all its attributes. And Turtle's screen just pretty much means this. It says Python Turtle graphics. It gives you a white canvas. This is just what Turtle provides you with. It's really handy. So you just type screen setup 1.1, 1.1, which means full size, and that's it. So begin. This line, what it do over here is this line defines a turtle object named T. So turtle over here is also a class, and then so this is a class, and then we want to define a variable under a class. So we're giving it all its attributes, all its functions. So the color, forward, left, these are all functions in the turtle class, and then this is pretty much connecting to what we learned in the first class. And then let's ignore all of these code for now. And then let's write some of our own. So in turtle, the default shape for a turtle is an arrow. This is yellow, so it's kind of hard to see. I'll take off the yellow and then turn it to like my keyboard is not working. Black. And then uncommon of these. So we can see that on default, we can see on the right side, the turtle have a default shape of an arrow, but then we can always redefine the shape. So what we should do, let me comment out of these, is t dot shape turtle. Yep. And now we can see that the turtle have changed from an arrow to a turtle. And then I don't know if that's why it's named after turtle, but then this is definitely one of the interesting functions we can use in here. Right. We can also adjust the pen size of turtle. So what we do is t dot shape size 222. Just try to remember all of those functions in yellow. Those are functions in the turtle library that we don't have to know how they are like functioning, but we just have to know that those does stuff. So shape defines the shape size define the size of the shape, and then let's see. We can see that the turtle have gotten bigger, and three. I think these are dimensions, which means like horizontal, vertical, and then yes. See, it's getting bigger and bigger and bigger. So let's turn it back to 111. And let me make a note over here. This allow. All right, everyone with me so far? Everyone know what's going on? Any questions? All good? All right. So next up, we have t dot speed. This is another very important function. It's about the speed that the turtle is going in. So let's uncomment all of these again. When I have one, it's pretty fast, right? But then I can turn to 3. It should be faster. Yep, it's faster. And then also if you want to do it like instantly, I remember it's turtle 0. It's instantly. It's not showing. I don't know why, but let me try this again. Yep, 0 is instantly. So you can see that it's very fast. The animation took pretty much no time, and then that's 0. And then 1 is the slowest. You can see that it's very slow right now. And then it can go up to like however much you want it to be. It's super fast. Let's put it back into its place. Define the speed turtle moves. This AI is pretty smart. And next we can actually have the turtle, we can have it draw. So the function we want to use to make it draw. So turtle is like a pen. Make pen, right? The function we want to use is called forward, right, backward, left. So these are all directions, and it means uh the places you want the turtle to go. So forward 100 means you want it to move forward 100. And like keep in mind it's direction sensitive. So the turtle have a head, right? And then wherever the head is facing is the front, and then forward, it'll go front. So forward 100, it'll just go to the right in this case, 100 because it's facing the right. And then turning will be turtle right. This will have it turn to the right for this parameter is degrees, so turn right 90 will be turn right 90 degrees. You can see that we use turn left here 90 to here to form a right angle, and then it closed out as a square. So this is turning. Of course, there's forward, there's also backward. There's also turn, not turn, left 90. Let's run this again. So slow down the speed. It's going super fast. It goes forward, it turns right, it backwarded over here, and then it turned left. So it's facing right at the end of all the procedures. So does everyone understand so far? Still pretty basic, but visualize, this is visualizing how you can manipulate the directions and distance it goes. And those parameter over here, I'm not sure about the unit over here, but then this is pretty much telling it how far you want to go. The larger it goes farther, the smaller it goes shorter. So if I change this to 50, you can see that it went half the length. It went up half the length, it went right. So that's that. Okay, let's move on. Let me comment all of these out. Let's take this part of the code. It's pretty handy. We can also change the color of turtle. So for C and 1, 2, 3, 4, which is like a for loop, so it's gonna go through it 4 times. So first time C is red, second time is green, third time is blue, last time is black. Turtle have defined all the color for you guys, so just type the name of the color and Turtle will know what's talking about. So in this, the first iteration, it will set the color to red, go forward 75, turn left 90 degrees, and then it will turn to green, go up 75, turn left 9 degrees, and then it will turn blue, it'll go left 75 and turn left, which is gonna make it face downward, and then last of all, it will turn black and it will go forward 75, which will close out the square, which is the square drawing thing we've just seen. Let's run it again to visualize. Yep, go forward 75, turn left, 75 left, 75 left, 75 left. This is how you should create shapes in Turtle. So I'm gonna give you guys a little challenge of how to write a triangle in Turtle. Challenge. It should be in the same format, but then iterate one less time, so only red, green, blue, and then you should think about the angle that is turning. Instead of 90, it should be something else. So I'll give you guys a few minutes to see if you can figure out how to draw a triangle on your own. All right, let me just take Ian's code to demonstrate for you guys. If you guys still are not quite sure, he used red, green, purple. That's fine. And then he used abbreviations. FD is just forward. I'll just type it out. Forward. It's forward abbreviated FD, and then LT is left. It's fine. You can type out the whole thing or use abbreviations. It doesn't really matter. And let's run it and see. Yep. This prints a triangle. So for equilateral triangles, the inner angle is 60, and then 180 to minus 60 is 120. So you want to have it go forward, turn left 120 degrees, go up, turn left 120 degrees, and go back to the place where it started. Very nice. Okay, so on to the next thing. So you don't always want to draw the turtle. You don't always want the turtle to be on the canvas. You don't want to drag it all around the places because it's going to be very messy. So turtle has this function called pen up. Pen up means that it will stop drawing no matter the positions it goes, it will not draw anything. Let's just add a t backward 100. So what this should do is it should still draw the triangle, but when it backs, you see that there's nothing drawn during the last period of going backwards. So that's pen up. And if you want to have it start drawing again, just say pen down, T forward, 100 forward, 100. Yep. See, it draws a triangle, it goes back without drawing, it goes forward, and it drawn. So, yep, that's that. Anyone have any questions? Till now, everyone's still with me. Should be still relatively easy. All right. Well done. Okay, I don't think I'm jumping over anything. Okay, the next function that is very handy, let me comment out of, is called t dot go to. This moves the turtle to a specific coordinate. So the first is x, the second is y. Let's say I just wanted to go to 0, 0. It'll go to the center, but like it's super fast, it didn't do anything. So I can say it goes to 2 or 0, 0. I can also make it go to like 100, 0, just to show you guys. See, it's moving right to 100, 0 directly. This might seem kind of redundant, but it's really handy when you want to create if you want to create like a shape with a certain pattern, you can use while loop, and then you can use go to instead of saying forward, left, forward, left, forward, left every single time. It's a very handy function. You can stack go to as well. Go to negative 100, 0. This should also work. Yep, it'll go forward and go backward. And note that the direction of the turtle doesn't change in go to functions. So not like turn, it always faces one direction unless you tell it to change or turn. What you can also do is call turtle dot home. This goes to home position. This is pretty self-explanatory. Turtle dot home just goes back to the center, default home position. All right, so let's have you guys do a second challenge. Second challenge is here. So draw a square with 4 different color sides and then a triangle with 3 different color sides, and make sure that those two shapes are separate so they're not touching each other. So what I'm saying is that I want a square on the left and then a triangle on the right, or like on the top, on the bottom, doesn't matter. But then just as long as they're not touching each other, they don't share the same side. Yep, I'll give you guys a few minutes to try this out. This should be a little bit harder, but still not too confusing, hopefully. Okay, I've seen one solution from Ian. Ian is super fast at this. The rest of you don't worry. I'll give you a few more minutes to try this out. This is pretty important, so Hopefully you can understand, or hopefully you can get this. In color. Okay, does anybody else have a solution or a code that they want to try out? If not, I'm just gonna paste Ian's into saying because I think his is correct. I don't have to write it again. So let's run it. Okay. Yep, you can see that a square on the left and then a triangle on the right. That's correct. That's super good. I'm not sure why the color is all black for the triangle, but then looking at the code, everything should be correct. Oh, because you didn't put t dot color. See. So again, it should have a triangle with multicolor. Yep. Um, red, green, purple, black, red, green, purple. Nice. So that's how you should create two separate shapes. See that he had pen up. What I don't know what is the um lifted pen up to move around. Put pen back down. Start. Right. All right, this is that, and then I'm gonna comment all these out to move on to the next function. Let's see, what am I gonna teach you next? All right, so now we can see on the canvas there's a lot of stuff. Actually, let me uncomment all of these. What we can do to erase everything is t dot clear. I think this is the function that clears everything. Yep, see after like everything is finished, um, it'll just erase everything, and that's what clear does. It's when you want to like reset or create a brand new different project, you just do t dot clear. All right, now I can comment everything out and do this. So what Turtle is also able to do is drawing a circle. So let's say T circle 50. What this does is the turtle will draw a circle with radius 50. Let's see how it works. Yep. It's kind of like edgy, but then you can see that it's still a circle with a radius of 50 as we defined. And then we can also do fill. I think the only thing I have to do is uh T begin fill. Pretty sure that's how it should work. Not really. Seems like okay. T dot 50 pinup go to 0. It's filling a shape drawn after. Oh, I have to move the circle thing to below this for it to show, I believe. Nope. 100. Oh, okay. T dot infill. Keep forgetting those functions. There's too many functions I have to remember for different libraries. Forgot the bracket again. Pretty lot of mistakes over here. Yep, you can see that the turtle filled in the color for the shape circle. And then that's another function that we might be using when we want to draw stuff. Is everyone still with me? Any questions, any concerns? Do I have to re-explain anything? Yeah, so like you don't necessarily have to be inside the circle. And then I think the mistake I was making is just you have to have begin, you have to have end, and then I was forgetting all those brackets and stuff. So it's majorly syntax. Okay, other than that, any other questions? All right. So don't worry about remembering all of the library functions in like on the top of your head. Like I don't think I remember everything. I just remember probably most of them and all the basic ones, like go to, backward, forward, begin, fill, circle, those kind of stuff. And then let's see. Let's have you let's have a third challenge for you guys. So third challenge, draw a stick figure. So what this is draw a stick figure. So do a head, which is a circle, and then under that circle, do a body, a line downward, two hands, and two legs. I would recommend using go to because it's easier to like remember the position you were in, but it's also fine. You guys want to use go forward, go back. It also works. So I'll give you guys a few minutes just to work on drawing a stick figure. It should look like a stick man after the program is ran. So a few minutes, work on this. All right, I've done the code and you can see you should probably go for something like this. It looks pretty ugly, but does anything. What was the syntax to return to the starting point? The syntax to return to starting point is this one, t dot home. It goes to the center of the page. So t dot home returns to default position. All right, so try creating something like this. You can make it like look better or whatever. It's just creating a stick man. All right, we're kind of running short on time. I still have a lot of content to talk about. So I'll just start going through my solution and then as long as you guys are doing about the right stuff, it's all right. Wait, I see. Oh, okay. I see Ian have gave me a solution using uh forward, right, left. Okay, let me try out his. Let's demonstrate. Let me comment my solution out. Okay. All right, his looks pretty nice. Let me just rerun it with a slower speed. You can see that he went up, draw a circle, went down a bit, two hands, and two legs. Finally, so let's watch it again. Two hands, body, and two legs. Well done. This is pretty good solution. Just forward, turn, forward, backward. It's pretty much just telling the turtles to go to different positions. Takes a lot of time, but should be fairly simple to understand. And then let's go on to the next concepts. We can for turtle we can get the current coordinates. What the syntax we want to use is print x coord t dot x coord print y coord t dot t dot. AI is pretty annoying as always. Okay, let's see. In a terminal here, it said y coord 0, x coord 0. This is because I have it at 0 position. If I say t dot forward, let's say 100, and then let's run it again. It still says go to. Okay, not quite sure what happened there, but then you can oh it printed. So x 100. Oh, this is a y coord. Never mind. Let's run it again. Run t dot forward 100. See, now that I have 100 and 0, so it can extract the current position that turtle is in, and then it will print out the coordinates. All right. What we can also do is individually set the x and y coordinate of the turtle. So what we can do is t dot set x, whatever x you want to set it to, like 57, for example, and then t dot set y, and then say 120. So we can see that first of all, it will go to the position you told it to go to, and then when we watch it again, we can see that it first went backward and then it went up. This is because we first changed the x coordinate and then changed the y coordinate. So it will first move horizontally, and then after the horizontal position is met, it will move vertically. And we can see in the terminal on the bottom right, it says x coord 57, y coord 120, which is exactly what we've set it to be in. All right, last function for today is called t dot, let me think, t dot let's do T dot hide turtle first. So whenever turtle is used for making a UI, a user interface, we can also hide the turtles so that only the shape is generated and we won't be able to see the arrows, the turtles. I'm not going to demonstrate this one, but I'll make a note when the turtle is UI. So pretty much what it does is that remember like when we draw stuff, you can see the turtle moving on the screen. Do turtle, hide turtle, we will not be able to see the turtle on the screen. And then turtle, what else do I have to teach? There's T dot stamp. T dot stamp. Wait, I've commented a code that I shouldn't have. The time. So T dot stamp stamps the shape on the canvas. So let me add the line back, screen dot loop. Turtle stamp, and then we can have a T dot forward 100 T dot stamp. This should stamp. Oh, never mind. I gotta do pen up. Yep, so now we can see that it's stamped the shape of the turtle in here, and it is stamped the shape of the turtle on the right. So we can manipulate this by changing the shape. Remember that it doesn't always have to be turtle. It can be arrow, it can be a bunch of other stuff. Just it will stamp whatever shape you defined the cursor, the turtle, or the entity to be in. It will stamp the shape at its position on the very moment. So that's that. And then turtle can also do it can also print messages on a screen. So I can do T dot right. Uh hello world. Let's see how this runs. We can see that let me just take this stamp away. It's kind of annoying. We can see that on the right it says hello turtle, hello world. So this is just printing the message that you want it to print. You can print whatever you can print. Um this is a defined font. And now we can use a tool called font. Font equals to Arial. I'll just use what the AI generated for me. Bold. I think that should give us this font equals Arial bold. I'm missing a bracket over here. Yep, it changed the font. It made it larger and it made it into Arial size 20. I can make the size of the text smaller. I don't know what font it supports, so I'm not going to change that. And then I think I can just take this away. And it will be normal instead of bolded. Yep, and I think these should be everything these are all the basic functions, and now let's do a practice. So practice, make turtle compass. So what we want is that we want to stamp 4 arrows on a north, west, south, and east. We want to say this is north, we want to say this is west, this is south, this is east. And then finally, we want the turtle to be let's make it in the middle of the canvas, and then after all the 4 arrows are stamped. So I'm gonna do it really quick and then show you guys how it looks like. Meanwhile, give it a shot and try to work on it using stamp, using array, using goto, and etc. If you want to make it fancy, you can of course change the colors, but let's just try and make a compass using turtle. All right, does anyone have a solution ready? I will just go through this because it's pretty long, but then it's also not very hard at the same time. So let me just go through this. You clear the screen, pen up, you go to home, and then this is the home location. And then you go forward, you stamp the arrow, you go back, and then you go forward, you stamp the arrow, and then you go up a bit, you write the name, you go, and then you go back to central location, you turn left. So essentially, it goes here, stamp arrows, type the east, went back. It went up here, stamped the arrow, went back, and typed the north, and then so on and so forth. And I'll send this code later in the WeChat group, so don't worry about not having time to finish. And there is going to be an important announcement. So everyone, so for tomorrow and the day after that, so Friday and Saturday, in American time, we won't have class, and then instead we will have office hours, and then during the office hours, you would be working on one of your own projects using Turtle, and then I'll be showing you some examples, and then we're gonna be having a presentation on Sunday, so we'll send out three different project choices in the group chat, and then you can either do one of those three, and then or you can come up with your own project and do like a short animation in Turtle. Either is fine. Just remember that in Sunday, 7 to 9 p.m. in class time, we will be doing a short presentation. The reminder will also be sent out to emails and WeChat groups, so don't worry if you guys forget. We'll remind you guys to do your project, and then meanwhile, if you guys have any questions or like problems concerning your project when you work on it, tomorrow and the day after, 7 to 9 p.m. in office hours will be a great time to find us, and then we will help you with whatever issues, problems, and explain concepts if you don't understand them again in these days. So let me quickly pause my sharing, and then I'll share you guys some of the interesting projects that you might consider doing. Hmm. Okay, I'm gonna share to you guys some projects. All right, this is a turtle race project we've done last time. Let me fork it real quick so we can see that. Let's wait for it to run. When I run it, it's not loading. Okay. When I run it, we can see there's four turtles. We set a race course. We'll have them go forward in 3, 2, 1, and then they'll race each other. And then we will see whichever one reaches the final line first. Give it a second. We can see the yellow turtle won. And then this is really easy as to give you guys some thoughts on this project. Just print those lines, and then every time go forward by like 20 pixels, print the line, print the line, print the line, print the line. And then we use a while loop. So while the turtle have not reached the finish line, we give it a random number. So a random number, let's say a 1 to 3, for it to move forward each second. And then whichever one reaches the finish line, you exit out of the while loop and then print real turtle wins. So let's just watch this animation again to give you guys an idea. It's loading, racing starts in 3, 2, 1. You can see it will start racing each other. Yep, until somebody finally wins. So this comments pretty much explains, and then create the turtles, move the turtles until someone reaches the finish line. Another project you can do is Turtle Sumo. This is super interesting. I've spent some time working on this. So you create two circles, you pair up the turtles, and then you have them fight each other and then see whoever get pushed out. You can see that red versus blue is going on first. It's pushing until someone finally gets pushed out of the circle. It's an very even matchup. Okay, blue turtle just won, and then it will run green and yellow in a second. So yellow turtle versus green turtle, so on and so forth. And then the winner of two matches will fight each other. I'm not going to show the whole thing. Oh wait, actually it finished pretty fast. Let's see the final match. Oh, never mind. I took off the code for the final match. Okay, this is another idea. So both of these are small Python projects that you guys can be working off over the next 3 days. And then if you have any questions regarding the programming part, just drop by in office hours. Every day, 7 to 9, we'll be here to help you guys. And yeah, this is supposed to be fun, so don't get too intimidated. And then just enjoy creating your own little game or animation or whatever is on your mind. Okay, it's 9 o'clock, and then I'm not gonna keep you guys any longer. So yeah, this is our last day of class, and then you can either make one of these or you can do another one of your own. That's on your choice. And then remember, if you have any questions, please come to office hours. We are here to help you guys. And with that, you guys are free to go if you don't have any questions. And then if you have questions, you can stay and ask.